treatment plant is implementing new sand filters, each with a surface area of 6 meters squared. Design flow rate to each filter is 0.044 meters cubed per second, and to ensure effective treatment, the design loading rate to each filter box is 150 meters per day. Determine the number of filter beds needed, then determine the loading rate when one of these filters is out of service. Okay, so first step, we want to be able to find the area we want, the total surface area needed, given a design loading rate of 150 meters per day. So we know that the loading rate is equal to the flow rate over the total area. So this tells us that the area we need is Q over the loading rate. In this problem, that is equal to 0.044 meters cubed per second divided by a loading rate of 150 meters per day times 1 day equal to 86,400 seconds. Okay, and when you do this, you should get, not a VA, but you should get an area equal to 25.34 meters squared. Okay, but remember, this problem said that each of these sand filters only has an area of 6 meters squared. So, to get the number of filters needed, we just take this total area divided by area of, let's say, one filter. So that's equal, oh, my dog is tangled in my microphone and we're good. Okay, so this is equal to, total area is 25.34 meters squared. Area of one individual one is 6 meters squared. So plug that in and you should get number of filters needed is 4.22. Okay, but here's where we're gonna run into some issues in a practical sense. We can't make 0.22 filters, right? We could only make an integer number of filters. And also remember that we want an even number of filters for construction reasons. So what we'd like to do is make 4 filters instead of 6, because we're pretty close to 4, but we need to check that we're underneath the maximum suggested loading rate of 235 meters per day. Okay, even if we want to be able to only treat, or even if we want a loading rate of 150 meters per day, we need to make sure that even in the worst case scenario, we're not going above this maximum guideline. Okay, so let's find what this loading rate would be for 4 of these filters. So VA is equal to Q over A, which again is 0.044 meters cubed per second times 86,400 seconds per day over a total area of 6 meters squared per filter. And we want to see what happens with 4 filters. Okay, so our total area is 4 times 6 meters squared, which is 24 meters squared. And if you plug this in, you should get a loading rate of 158 meters per day. Okay, this is underneath our 235, so we should be good. But what happens when one of them is out of service for cleaning? We want to make sure we're still within guidelines then. So let's check again. Same formula. Same numerator as last time, which is not that. 0.44 meters cubed per second times 86,400 seconds per day divided by 6 meters squared per filter. But now what happens if we only have 3 filters in service? And if you plug this in, we're at 211 meters per day. Okay, so even in the worst case scenario, we're still underneath this maximum loading rate, so we should build 4 filters.